Hello, this is Mrs. Dehn-Brastad, and in this lesson we are going to talk about Chapter 5, Section 6 on the quadratic formula. So this is yet another way that we will have to solve quadratic equations. We will also use it to classify roots using what's called the discriminant of the quadratic formula. So what have we learned so far? You've learned how to solve quadratic equations by graphing and seeing where the x-intercepts are. You've made tables, you factored, you used square roots and also completed the square. And now we have another method called the quadratic formula. The quadratic formula comes from completing the square. And this is where it comes from. I'm not going to go through all of this, but if you want to find out where the quadratic formula comes from, it comes from doing completing the square over and over until someone figured out that there was this kind of shortcut way of doing it, and that resulted in the quadratic formula. So here it is. You will want to memorize this if you can. If not, keep it handy. We will use it a lot for the rest of the school year, and you will use it if you take pre-calculus and calculus, it'll come up over and over again. So first of all, if you write your quadratic equation, your quadratic function in standard form, you would have ax squared plus bx plus c equals 0. So make sure it's in that form. Then you will be able to tell what is a, what is b, what is c. The quadratic formula says that if you take negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, that will be what your x is equal to. Now, because of the plus or minus part, you will usually get two answers here, unless it's like 0 underneath the radical, then you'll only have one answer. You can use this even if the part underneath the radical is negative, because now you know about imaginary numbers. You can use the quadratic formula to solve any quadratic equation. So even if maybe factoring would be easier, or completing the square, or graphing, you can still use the quadratic formula also or instead of, and you will get either real answers or you can get complex answers. All right, let's look at an example. This is one of the problems from your worksheet, so you might want to take a minute, pause the video, and find where is this problem on your worksheet, and then you could do it along with the video. All right, so we have f of x equals 2x squared minus 16x plus 27. Check and see if that's written in standard form. Let's see, we've got something x squared minus something x plus, yep, it's in standard form. Set it equal to 0. And now a is 2, b is negative 16, and c is 27. Make sure that you use the b as negative 27. I'm going to write those down. So a is 2, b is negative 16, and c is 27. This negative 16, the negative goes with, so I'm going to turn that purple. There we go. All right, so now let's see what we do next. We're just going to substitute in. Every time you see an a, you'll put a 2. Every time you see a b, you'll put a negative 16. Every time you see a c, you put in a 27. Now, be very careful because it's kind of a complex formula. So we have negative negative b, or negative negative 16, which is positive 16, plus or minus the square root of, then you'll take negative 16 and square it, minus 4 times 2 times 27, and then that whole entire thing will be divided by 2 times 2. Simplified, we would get 16 plus or minus, don't forget there's plus or minus, square root of 256, and then remember the order of operations says we need to multiply all of these before we do any subtraction. So 256 minus 216, and then the whole thing over 4. And then we keep going. 256 minus 216 is 40. So now we have 16 plus or minus square root of 40 over 4. Now that's not done yet. We can simplify even more. You can simplify the square root of 40. The square root of 40, remember simplifying radicals, that's the same as, let's see, 4 times 10. So that'd be the square root of 4 times the square root of 10. The square root of 4 is a perfect square. So we'd have 2 times the square root of 10. So where we had this, it becomes 2 square root of 10. So now we have 16 plus or minus 2 square root of 10 all over 4, which can be simplified even more, because if we divide both this And this by 4, or factor out a 2 out of everything, a 4 out of everything, we would get, one way to write it would be the way they wrote it, 4 plus or minus square root of 10 over 2. You could also have written this as, let's see, if I divide this by 2, I would get 8, and this by 2, that would be 1. So I could have wrote this as 8 plus the square root of 10 over 2. That would also be correct. Now it's plus or minus, so there's two answers. One of them would be 8 plus the square root of 10 over 2. The other one would be 8 minus the square root of 10 all over 2. Or 4 plus the square root of 10 over 2, or 4 minus the square root of 10 over 2. So there's really two answers. Here's another example. So the first thing you do is set it equal to 0, make sure it's in standard form. Then pick out the a, which would be 1 in this case. I think our a's were red. So a is 1. If there's no number in front of the x squared, it's not 0, it's 1. B is 3. C is negative 7. And then there's the quadratic formula. Start to memorize it, and then replace every a you see with 1, every b you see with 3, and every c you see with negative 7. And then we simplify. These numbers are a little smaller. So we'd have negative 3 plus or minus 3 squared is 9, minus 4 times 1 times negative 7 would be a plus 28. Add the 9 plus 28 and get 37. The square root of 37 is, you cannot simplify that anymore. So you could leave this as your answer. There's no common factors in any of it, so your answer would just be that. You don't have to write it as two separate answers if you include the plus or minus, unless it was something, really easy to simplify, like 3 plus or minus 5. Then if you have just whole numbers, then yes, go ahead and simplify farther. Okay, here's another one from your worksheet. So again, you might want to take a minute, see if you can find that one, and follow along. All right, first we are going to set it equal to 0 and make sure it is written in standard form. I'm also going to put a 1 in front of the x squared term so that I know that a is equal to 1. So a equals 1, b equals negative 8, and c equals 10. So now I'm going to replace each of those variables in the formula with what they are equal to, and then simplify. So we would have 8 plus or minus negative 8 squared. Remember, negative 8 times negative 8 would be a positive 64, and here we get negative 40. So this square root of 24 can be simplified. Let's look at that. Let's see, it's 12 times 2. That doesn't help me much. 8 times 3. I'll have to go with 4 times 6. So the square root of 4 times the square root of 6. And I picked those factors because the square root of 4 is 2. So I can simplify the square root of 24 to 2 square root of 6. So I can replace this. Now you'll see that there's a factor of 2 in each of these. So they divided 2 goes into 8 4 times, 2 goes into 2 1 times, and you're left with 4 plus or minus the square root of 6 as your simplest answer. Here's another example, and in this example, you'll see that we might get a negative inside the radical. So we set it equal to 0, and then we pick the a, b, and c. So a is 4, b is 3, c is 2. So in the formula, we just do the same thing as we've done before, replace each variable with what it is equal to, except this time, when we do that, we get a negative 23 inside the radical, inside the square root. So we have negative 3 plus, the plus or minus disappeared, plus or minus the square root of negative 23. Now negative 23, there's no perfect square, there's no factors of 23, it's prime. But we could write this as I times 23, because this would be the square root of negative 1 times the square root of 23, and we know that the square root of negative 1 is I. So we can simplify this by writing the I, and they wrote it after the square root of 23 over 8. You could have written this as negative 3 plus or minus the square root of 23I over 8 as well. That wouldn't be wrong. When you're doing these on if you're typing with Word, put this stuff around in parentheses before you do your divided by 8, if that's the way you're going to write it. Use parentheses around the numerator because there's going to be a lot of stuff in the numerator. And for square root, I usually just type square root. So I'd type square root of 23. Boy, then you'll have to do the times I guess, using the asterisk key for your multiplication symbol. Yeah, it's a little tricky to write all this using Word. There are formulas in Word if you want to go to insert formulas. Quadratic formula is one of the default formulas that you can use, and then you can just fill in the different parts. All right, so here's another example, and this one again is from your worksheet. So you set it equal to 0, and then pick the a, b, and c. So a is 3. Now there's no number in front of a b, but it says minus x, which means that b is -1. C is 8. Replace each variable with what it is equal to using substitution property. And then we will get, so -1 squared is 1. 4 times 3 times 8 is 12 times 8 is 96. So we have 1 minus 96, which is -95. And -95, let's see. I don't think you can simplify, you can't simplify the square root of 95 except that the negative part. So you can write -95 as -1, square root of -1 times the square root of 95, which then is I times the square root of 95, but we put the I at the back. So again, if you were typing this, you would write square root of 95, and then the multiplication symbol on the keyboard looks like an asterisk, like a star, and then your I. And then it's divided by 6. And don't forget the plus or minus as well. There's 2 answers, so you need the plus or minus. All right, the discriminant, that is just the part of the quadratic formula underneath the root. So not including the square root, just the b squared minus 4ac. That's the discriminant, b squared minus 4ac. So if you have your quadratic function written in standard form, then you can pick what is a, what is b, what is c, replace it, and you'll get a number here. All right, so depending on what you get for that answer, tells you what kind of a function you have and how many roots it has. If you get a number that is greater than 0, a positive answer, like 6 or 7 3/5, then you will have 2 distinct real solutions. It'll cross the x-axis twice. If it's equal to 0, that means that there is 1 real solution. It's going to touch the x-axis at 1 and only 1 point. If you get a number less than 0, a negative number, that means that there are no real solutions, but there are complex solutions. There are 2 of them, and they will both have I as part of their solution. All right, so let's look at an example. This one, again, is on your worksheet. Now, this is not yet in standard form, so first you need to rewrite that in standard form. And I did that by subtracting 12x from both sides and setting it equal to 0. Then make sure that you have it in descending order. So the ax squared plus bx plus c is how you write it. So a is 1, b is -12, c is 36. Now the discriminant is just that part that was underneath the radical, the b squared minus 4ac, not including the root. So now I replace b with -12. -12 squared is going to be 144 minus 4 times 1 times 36. That's also 144. So we get 144 minus 144, which is 0. That means that there's going to be it's going to be this, one distinct real solution. So it's just going to touch the x-axis at 1 point, if I was going to visualize what was happening here. So the answer for this question says, find the type and number of solutions. There's going to be 1 real solution, 1 distinct real solution. Now, when you solve this using factoring, maybe you got x equals 2 and x equals 2. Those aren't distinct. That's 1 solution. All right, again, this one is not yet in standard form, so you need to rewrite it in standard form. Then a is 1, b is -12, and c is 40. So that is 144 minus 4 times 1 times 40 is 60. Minus 160 is negative 16. So we got a negative answer. When you get a number less than 0 for the discriminant, that means there's not going to be any real solutions. It means that your graph will never cross the x-axis. But there are two non-real complex solutions. That's what you would write. Two distinct non-real complex solutions. Seems like a mouthful, but that's the answer. Here's another example. Again, this is not yet in standard form. A little bit of practice rewriting these in standard form. Remember that A is 1, B would be negative 12, and C would be a positive 30. Replace those into the discriminant, and you will get 144 minus 120, which is a positive number. And a positive means that you will have two real solutions. It'll cross the x-axis at two places. All right, here's an example that's from your worksheet. Again, you need to write it in standard form. So subtract 2 from both sides, set it equal to 0. A is going to be 1, B is going to be negative 4, and C is going to be negative 2. Plug those into the discriminant, b squared minus 4ac. So we'll have negative 4 squared minus 4 times 1 times negative 2, which is negative 4 times 1 is negative 4 times negative 2 is plus 8. So 16 plus 8 is 24. That's a positive number. So you will have two real solutions. Here's some examples where every one of these is x squared minus 6x. See that? They just changed the constant. And you can see that changing the constant moves it up or down on the graph. And when you move it up or down on the graph, that changes how many times it will cross the x-axis. So when it was plus 7, it crossed the x-axis 2 times. When we moved it up, it only touches at 1 point. When we move it up even more, it's not going to touch the x-axis at all. So we learned about translations, and we know that this at the end changes how far up or down you're going to move it, and that's the result that you see here. Now, it needs to be written in vertex form to see exactly how that's going to change it, by how much, but you can see that changing the value of C is going to change how many real or non-real solutions you have. This is just a summary of all the different ways that you have to solve quadratic equations. It's in your textbook. It's also on your worksheet. And there is a question in the journal that asks you to describe some of these different ways. So graphing works really well when you only need approximate solutions or when it's crossing at really nice exact answers. If you have a real simple quadratic equation, you can use graphing technology to zoom in and get a good approximate. Factoring is great when it's possible, but it's only possible in some situations. It's always a good idea to check and see if you can factor a quadratic equation, because if you can get your answers pretty quick. You can get a solution with just taking the square root of both sides if you just have a perfect square equal to a number. So there's no other stuff on it. It's just take the square root of both sides and you're able to simplify and get an answer. That works once in a while. Completing the square works. It works best when your problems are not too complex, like if A is 1 and B is an even number, because you have to take half of it and square it. That's a lot easier if taking half of it gives you a whole number. And the quadratic formula, that's really for any other time that these other methods don't work or are too complicated to make work, then quadratic formula. So use it for sure if you have larger numbers or more complex. If you have something besides 1 here for the A, quadratic formula is better. If it doesn't factor easily, even if you think it should factor but you can't figure out what the factors are, try the quadratic formula and you'll be able to find those factors. So there you go. That's it for today. Make sure that no matter which method you use, you're always going to get the same answer. That won't vary. And if you have any questions, let me know, and I'll be glad to help you out. Thanks a lot, and have a great day.